Okay. So right now, what we're trying to do for this lesson, we're gonna use word problems. I know, you're not the only one, but we have to live with it, because when we do math, if you ask me when do we use math, it's to solve word problems. Okay, everything you're learning is to solve word problems. So, modeling word problems using linear systems. Remember we talked yesterday, linear systems is two equations, right? Where I can solve them to find the point of intersection, and that would be my solution, where the two lines intersect. So, to model a word problem using a system of linear equations, you must, first thing, you must declare your variables, which means using let statement, which means you can't just start an equation and write an equation y equals 7x plus without telling me what does y represent. What did I say? Yeah. This is declare. Just my thing does not write properly. Declare. Using what? Let. Okay, sometimes I write the cursive writing. Okay, does that make sense? Alright. Okay, so you can't just go ahead and write y equals 7x plus 1 without telling me what y represents and what x represents. Or you can't go and write m equals 3c plus 2. What does m mean? What does c represent? You have to say let m be money, whatever the question is done. Okay? So always when we're doing this, we have to start with a let statement. Okay? So we're gonna let this variable be this, and this variable be that. Create each of your equations. So after you do your let statement, you're gonna create each of your equations. How many equations are you gonna have? It's a linear system. How many equations are you going to have? Two. How many letters are you going to have? Two. Okay? It's going to be 2 letters, 2 equations. So, there are 2 types of linear system problems that can be modeled. The first one is when you have a single scenario under different conditions. So let's look at an example. Jason weighs 6 kilograms less than twice Bill's weight. If the sum of their weight is 102 kilograms, how much does each person weigh? So what do I have to start my problem? Let statement. Okay? So let statement, that means I have to let this variable be this and let that variable be the other. What are the things that I'm comparing here? What are the things that I'm trying to solve for? The weight of who and who? The weight of Jason and the weight of Bill. Right? So these are my variables. What do you want to call them?
J and B.
J and B. Perfect. Okay? So we're going to say let J be Jason's weight and let B be Bill's weight. So this is where you're going to start your let's say. So you see how I asked myself, what am I trying to solve for here? What's the question asking me to solve? And these are going to be your letters, your variables. Good. Now we're going to have to write two equations. Okay? The equation should have the two letters, J and B. Nothing else, no other letters. It's either J or B, or both. So let's read the first sentence. Jason's weight is 6 kilograms less than twice of Bill's weight. Can you give me an equation that models this?
B equals J bracket 102 bracket minus 6.
Why am I using 102?
Because that's the original weight, so if you divide it by 2.
What?
Well, if it's
No, we can't do that. Just let's not, don't worry about the second sentence, just the first sentence. So Jason's weight is 6 less than twice of Bill's weight. So Jason's weight is what? So Jason's weight is equal to what? B times 2, so 2B. It's 6 less
Plus 6.
minus 6. Right? Twice is Bill. That's twice Bill's weight. Right? So if Bill is 100, then 100 times 2 is 200. Right? That's what it's saying. Twice of Bill's weight. But it's 6 less than that. Okay? So when you see the word less, that means you're taking away. You're subtracting. When you see the word twice, that means you're multiplying by 2. Okay? When you see the word more, then you're adding. Does it make sense? Yeah. Good. So this is the first equation, and I got this equation using the first sentence. Now let's look at the second sentence. If the sum of their weight is 102, the sum of their weight. What's Jason's weight? What is the letter that represents that? What's the letter that represents Jason's weight? J. What's the letter that represents Bill's weight? B. The sum of their weight, so that means what? J plus B. What does it equal? 102. Now, do you see that I have two equations? Do you see that each equation have J and B in it?
Yeah.
Good. This is my linear system. Okay? Now, at this point, we're going to stop right here. But in reality and later lessons, we're going to be solving. So not only we're going to make the equations, we're also going to have to solve for it. Remember yesterday we graphed, right? But I told you not only we're graphing, we're also going to be using elimination and substitution to solve. Okay? But for now, all what we have to do is write the equations. Okay? Are you guys okay with this? It's going to take some time. You have to read the question and you have to understand what you're reading. If you don't understand the English, it's going to be a problem. The second type of questions that we're going to get is when we have two scenarios under the same conditions or similar conditions. So when it gets to this, it's you have two different, let's say, companies, but we're comparing the same thing. Okay? We're talking about two different companies that are doing the same thing, but they're charging different things. So for example, if you want to talk about Bell, right, and how much Bell charges you for a phone versus how much Telus charges you. right? So there are two different scenarios, but they have the same, we're talking about the same thing. How much does it charge you for? Okay, so let's read this. Carl's Towing charges $80 plus $0.22 per kilometer. Bev's Towing charges $70 plus $0.3 dollars per kilometer. Write a linear system to represent this problem. So what am I comparing? The total towing charges, right? So how much is it gonna cost me to tow something? Good. So we're gonna, what would be my let statement? So both of them are comparing the towing charges, right? So how much money it's gonna charge me at the end. So I'm gonna let C be my total charge, right? But what do they both, so let C be the total charge. Now what would be my second letter? What is my charge depending on? How much I'm gonna pay, what is it depending on? The kilometers. So give me a letter for that. Let K, okay. Let K be the number of kilometers. Total. Good. So let's compare both equations. So I have Carl's Towing, and I have Bev's. What would be the charge of Carl's Towing? 80. But are you only paying 0.22 no matter what?
No.
What are you paying then? Per kilometer. So what does that mean?
K.
That's right. Times K, right? You have to multiply that by, because this is, you're going to pay per kilometer, you're going to pay 22 cents. How many of you understand that part? It doesn't matter. If you write it this way, it's exactly the same thing. Okay? So, Carl's gonna change the $80 no matter what. Okay, we call that the initial value or the y-intercept. And then for every kilometer they're gonna tow you, you're gonna have to pay the 22 cents. Now, what would be Bev's towing? What would be the charge for Bev's towing?
C equals 70 plus 0.33.
Okay? Now in this case, I have two different scenarios. Scenario number one, which is Carl's towing. Scenario number two, which is Bev's towing, right? But I'm comparing similar conditions. They're both towing. They're both, I'm looking for the cost, and I'm looking at how many kilometers I'm driving, right? It depends on how many kilometers I'm driving. So these are your two equations, okay? I again, it doesn't matter if you write 80 plus 0.22 kilometers, 0.22K plus 80, or if you write 0.3K plus 70 or the other way. Are you guys okay with this? All right. So we're going to look at examples. For these examples, you're going to model each of the word problems using a system of linear equations. You do not need to solve the problems. We're just going to set up the equation and that's it. We're going to stop. We'll talk about solving the problems later on. Jill makes 2 types of quilts. The first type costs $25 for fabric and $40 per hour for hand quilting. The second type costs $50 for fabric and $22 per hour for machine quilting. For what number of hours are the costs the same? Model this problem. Now, my question to you, is this similar to the first question or to the second question? Good. What are the two things that I'm comparing? Cost and the time, the number of hours. Good. So what would my left statement be? Left? Mm-hmm. Sorry? What would be my second thing? Sure. Perfect. Let T be the number of hours. Good. Now, what would be the equation for the first type of quilt?
C equals 25
Yeah?
plus 40 T.
Excellent. Right? Because $25, they're gonna pay $25 for the fabric. It's not gonna change. But it depends on how many hours each quilt is gonna take to make, right? And she's gonna charge $40 for every hour that it makes, that it takes to make. How about the second type?
C equals 50 plus 22 T.
Yeah. Who thinks that they've got this? 2? Only 2?
Kinda. And the only thing I would do is like make sure it's super normal. I feel like I'm always reading. Like I just.
I don't know, that's what I thought.
The word problems really get me.
Okay. A band held a concert in its hometown. A total of 15,000 people attended. The tickets cost $8 per student and $12.5 per adult. The concert took in a total of $162,500. How many adults came to the concert? Model this problem. read that question again. What would my variables be?
People attending?
Does it make a difference if they're adults or kids?
No. No, yeah, it does, because the cost is different.
The cost is different, right? So if like 1,000 adult came versus 500, the cost is different, right?
Mm-hmm.
So that means my variables are going to be what? That's right. How many students showed up? How many adults showed up? Right? And always look at the kind of the question, right? And it's gonna give you a hint. What would your variables have to be? How many adults, right, showed up? So that's one of the variables.
Mm-hmm.
And the other one would be the kids, right? So let what? Let A be the number of adults. Or adult tickets. And let S be the number of student tickets. So, we did our let statement. Let's read the question again. A total of 15,000 people attended. What does that mean? Yes. But how would I write that as an equation?
Is that the Y?
15,000. I want to know how many, like, the question is saying that a total of 15,000 people attended. So let's look at this. There's 10 students in this class. There's females and males. I have a total of 10 students in the class. How would I write the equation for this? There's 10 students in the class, right? We have males and females, right? How would I write the equation for that?
Y equals B. No, 10x plus
No, because that's the number of adults, not just adults, it's saying like for students and.
Students and
A
adults?
plus B equals 15,000.
A plus S equals 15.
Yeah, that's what I meant, A plus S.
Yeah.
It was the exact same thing as the first question we did.
Yeah. Right?
Okay.
The number of adults plus the number of students equal to 15,000.
That took me a little bit.
It took her to actually say the sentence herself to figure it out. Yes. Right? So the total, when it tells you the total, that means you're adding your variables, right? Now, each student ticket costs $8. How many tickets did I sell? How many student tickets did I sell?
We don't know.
But we know the letter.
Oh, yeah.
X.
So, would it be A times the amount, so 8?
A times
$8, or, no, it's.
$12.50.
Oh, yeah, that's what I meant,
Yeah.
And then
plus S.
plus S times 8,
Equals to?
50,000.
No, 127.
Oh,
Because the money has to be added together to make money,
Okay, yeah.
right? The number added together to make a total number.
Mhm.
Okay? So each each student costs $8, right? So if I multiply S, right, that would give me how much each, like all the students have paid together. Each adult costs $12.50, right? So if I add them together, that would give me my total amount that I made at the end. Okay? Which is 162,000. And there's no number. Okay? Because every student paid $8. And every adult paid $12.50. And altogether we made a total of this much money. Okay? You see how money plus money makes money. Right? And this is how you always have to think about it. Right? And in this case, number plus number makes a number. Okay, number of tickets for students, number of tickets of adults, make a number of people attend. Okay? Is this question done? Is it done? Yes. Yes, it is. Yes, it is. Okay. So I'm gonna stop this.